Suppose we have Cobb Douglas production function, okay, and which is Q equals to root of KL. You're given with R as the rental rate of capital and W as the wage rate of labor. You set up a Lagrange and you try to minimize this cost which you have, which is WL plus RK, subject to this constraint. 80 minus root KL. 80 is that you want to produce Q equals to 80. Fine. You can have just Q also here, it doesn't matter. But say you want to produce Q equals to 80. I just want to put one point forward. I'll tell you why I've taken this 80 or any other number it could be. So del L by del L would be W minus lambda root K upon 2 root L equals to 0. You find the second partial derivative, del L by del K equals to R minus lambda root of L upon 2 root K equals to 0. And del L by del lambda would be 80 minus root of KL equals to 0. So how many partial derivatives you have found out here? 3. One for each variable, or one for each endogenous variable. Both of these are endogenous variable. They are determined within the system. And one for the constraint. Fine. Now if you divide first by the second, you will be getting this. W by R equals to lambda root K upon 2 root L divided by lambda root L upon 2 root K. On simplification, you will be getting this lambda will get cancelled out, 2 will get cancelled out. Root K by root L upon root L by root K. So it could be written as root K by root L into root K by root L, which is W by R equals to K by L. Fine. Now, suppose W and R are both 2. Fine. So, are both 2. Then K by L could have been 2. Fine. That is just using 2 units of labor and 2 units of capital. Let's see, can you produce the amount? Can you produce 80? That is, so Q is equal to, you need Q equals to 80. Fine. What you are saying is, this is root K root L. And with just 2 units of labor and 2 units of capital, you would be just producing 4 and not 80. Fine. Now the point is, this is just the ratio. Fine. You need something else. Say for example, you probably need 80 units of capital and 80 units of labor in order to produce 80 units of output. So you would need 80 units of capital and 80 units of labor to give you Q equals to 80. Fine. And that would give you the minimum cost. That is 80 into 2 plus 80 into 2. You will have the cost of 320. Can you find some other combination also which can also produce 80? But still, that is not be a minimal cost. Say for example, you want to produce Q equals to 80, and you use L equals to 144 and K equals to 44.8 or something. Okay, this you can find out. You know what? You can say that 80 equals to root of 144 into K. Fine. So this would be 80 upon 12, which will be 6.67 equals to root of K. So K will come out to be 44.89 or something. Fine. Say it is equal to 45 approximately. So what is the cost here? Even 144 units of labor and 45 units of capital can also produce 80 units of Q. But can they do so at the minimum cost? No, because it is 144 into 2 plus 45 into 2. This will be something about 288 plus 90. This will be something about 378, which is far above than 320. Fine. And you know that this was not in the ratio of 1:1. And that is the reason it is not able to minimize cost. Fine. You can also find out something else, okay? Of course, your 160 units of labor and 160 units of capital could also have produced 80 units of Q, okay? They could also have produced even more than that. But can they do so at the minimum cost? No. Fine. So this is the point. This is the point of cost minimization, that at the minimum cost, your ratio of input prices should be equal to MRTS L for K.